How will the next generation of chemical engineers solve emerging challenges around post-COVID recovery, net zero and digitalisation? The Department of Chemical Engineering at Loughborough University is developing forward-looking programmes underpinned by their world-leading research activities to train 21st century chemical engineers with new skills critical to meet the needs of tomorrow's society.
In the labs at Loughborough University, the next generation of chemical engineers is preparing to change the world around them. Here, a student-led approach to learning is driving the ambition to make a positive difference.
One of the things actually that's quite dear to my heart that I think chemical engineers can really have an impact on is the disproportionate kind of effects that something like climate change, for example, has on developing countries. So how do you design the most sustainable technologies? How do you have less of an impact on the people that you're designing the technologies for and the environments that you're working with? And so that can actually bring us out of some of the sticky situations that we're in right now.
For recent graduate Alex, it's this approach to learning she's taking into the workplace.
The university material is really reflective of what I do at work. I'm currently reviewing different separation technologies to see which is the most sustainable in terms of the waste it generates and how it integrates into our existing processes. At Croda, everything we do aligns with sustainability. One of the biggest things is systems thinking. You don't want to just look at the process that you're doing, you want to look at the whole thing. So for me, it's our life cycle analysis means we can look at our process and we might find that there's a small part of a process which can greatly improve the efficiency. And from experience of doing this at Loughborough University, I'm able to understand the process better and help see where do we need to focus.
Digitalisation is one of the ways chemical engineers at Loughborough are using the latest technology to prepare for the world of work. So I can see why they call it the igloo. What does this enable you to do?
So this enables students to learn what it would be like in a real plant. It's obviously a simulation, and any change within this will be seen on within the simulation. So for example, opening this valve will release the pressure as seen on the pressure gauge at the top there, and of course you can then close the valve and it will raise up again, and students will then learn a proper cause and response within the simulation.
So you can simulate the entire production process, albeit in a virtual world?
Yes, exactly that.
And Tim's now using the same technology to model sustainable ways of manufacturing pharmaceuticals as part of a project with commercial partners.
If you match them together, you can then begin to use artificial intelligence and machine learning so that the process is continually optimized. In a layman's terms, I'm looking at creating a digital version of what's going on in reality. So in a sense, it's a bit like a video game. Video game, you might be running around. In real life, you might be running around. And you can simulate this between the two. With a digital twin of the pharmaceutical process, I'm working towards making a process which digitally runs the exact same as it would in real life as well.
The 2050 drive to net zero has fundamentally shifted the way of working in the chemical industry, and we need to create new jobs that do not exist even today to tackle some of the most pressing challenges to decarbonize our energy and industry, and that's our chemical engineering's job.
And that's also evolving the curriculum to keep pace in areas like the circular economy and the wider societal context.
We teach the students the new technologies, the policy development, the economic aspects, the social awareness, the whole system thinking, alongside the technology development. So we don't want them only to be the future engineers, we want them to be the engineering leaders that can tackle the most pressing challenges and can drive the great transition happening in the chemical industry.
I think the difference with chemical engineering is that it's such a broader picture. You're not just doing the maths, you're not just doing the science. Actually, there's an interconnection with many different industries. You work with the chemists, you work with the people who are scaling up, so the mechanical engineers, the people who are doing that kind of work, and you work directly with the society as well. So yeah.